about quadratic functions. Okay? Quadratic is misleading. Because you guys know what quad means. Four. Really not much, a little research, and we found out where it came from. But quadratic, that's what goes in this first blank. 2a, TIC, 2. The power is the x, we got an x squared. Okay? What did we call it when we graphed something that was x squared? We did not call it a parabola. We call it a parabola.
Parabola.
Parabola. Everybody say parabola. Parabola. And a U. Okay?
This makes a full circle.
Squared, they're going to be a circle. But only the x is squared with the, you could not figure where the name quad read. And guys, what does the prefix quad mean? 4. How many sides does a square have? So they said it had something to do with being squared from the Latin word square, had 4 sides, so they call it a quadratic. I don't know if that's true. Okay, so a quadratic graphs a parabola. Do not call them parabolas. Parabola. And did we talk about when it's upside down?
Yeah.
Yesterday?
Yeah.
What if your parabola is upside, your U is upside down?
It's all negative numbers.
No, just the x squared is going to be negative. Okay? That graphs of it upside down. We're going to do some of those. All right, its graph is U-shaped. Opening upward or downward. It can be written in the form. Here's our quadratic generation. Y equals ax squared plus bx plus c. It's kind of big. Just jot it down. Not expected to really understand that whole thing yet, but we're going to get there. A, B, and C are going to be numbers. Your y and x are going to stay y and x squared. The only condition is that a can't be 0, because if a is 0, the x squared goes away and then it's linear. So a cannot be 0. All right, this graph is called a parabola. Okay, it opens upward if a is positive. Okay, and that's that coefficient, guys, of your x squared. The thing in front of your x squared. If that's positive, it opens upward, and it's downward if a is negative. And we're going to give ourselves little hints as we do this. All right, here's the deal with quadratics. You know how you guys made tables to graph lines? How many x's did I kind of encourage you guys to choose? 4. 3 or 4, usually 4. Okay. With quadratics, you got to choose more than 4.
5.
At least 5, sometimes 7, and you'll see why. Okay. So that's why the tables are going to be a little bit. All right. To graph a quadratic function, you're going to make a table of values, plot your ordered pairs, and connect the points with a smooth curve. Do not use a straight edge for quadratics. It's not going to be straight. Okay. And then the one thing I want to encourage you guys to look for, okay, is to look for symmetry. We talked a little bit about that yesterday. Parabolas are symmetrical. They're the same. If you split them in half, they're the same on both sides. So that's what you want to look for, is the symmetry. Okay? All right, let's do the most basic one. Y equals x squared. X squared. All right, what's the smartest x value to start with?
1.
There's a
0.
better one. That's the second one.
0.
Always start with 0. Okay, so let's put 0 in. Hopefully we don't need our calculator yet. Y equals 0. Oh, put parentheses around your values when you plug them in. That'll help you be careful with your signs. And who can square 0 in their head? 0. So when x is 0, y is 0, this parabola actually goes through the origin. So you want to graph the point now, you can graph it later, whatever. Now what's the next best x value to choose? 1. Y equals 1 squared. Still 1, right? Because 1 times 1 is 1. What does the knucklehead kid say 1 squared is?
2.
2. It's not 2. It's 1. So 1, 1 is also a point. on there. Okay, next smart x value to choose?
2.
2. Y will be 2 squared, which is
4.
4. So now we're going to recognize that it's not linear. Because look, the 3 points don't line up. It's not linear. Okay? Next best x value to choose.
-1.
Both correct answers. 3 or -1. Okay? Just because I'm doing the positives right now, I'm going to stick with 3. Let's watch what happens when we get to 3. The y values get big fast because you're squaring x. Okay? What's 3 squared, people?
9.
9. So what does the knucklehead kid say?
6.
6, as I just wrote. 9. So 3, 9. We're 1 unit off the table, off the graph. No big deal. Just use your best judgment. Okay. Without any, what would 4 be? What would
16.
16. Oh, we'd be way off the graph. Okay. So we're not even going to try 4. Let's go to -1 now. This is why our table's doesn't have a bottom. You're gonna have to try a lot of values. Definitely use parentheses here, people. -1 squared. Don't say it if you know it. Put parentheses around it. Raise your right hand if you know what -1 with parentheses around it squared makes. Big Don.
1.
+1. Very good. Okay. Now, -1, 1. Here's what I need you guys to do. Always be looking at your y column. Ever see the y values? Are they starting to repeat? Which number is repeated?
1.
The 1, guys, is repeated. Look, 1 is we see it twice in the y column. Okay? That means we have that symmetrical aspect going on. Okay? Look at your graph. You guys have your points graph? Okay? Do you guys see 2 points that are kind of like on the same level? Okay? That means it's starting to be symmetrical. Let's try -2 and watch what happens. Y equals -2 squared. Tara Burke, in your head, what do you think -2 squared is? 4. +4, because 2 negatives are going to make a positive. So notice, watch what happens now. -2. Did the points line up across from each other? Guess what -3 is going to make?
9.
9. I'm not even going to do it. I'm just going to put it.
Mr. P,
Yes, sir.
did you have to do the 6 and 7?
What's that?
The 2 that are 9s?
You kind of want to know where it's going to be. So yeah, it's smart to do.
Okay.
Okay. Don't get lazy. All right. Do you see? We haven't even connected yet. But do you guys see a U? Is it a big wide U or is it a skinny U?
Big.
Look at it.
It looks
I
like
think
a
it's
V.
skinny.
Skinny.
Okay. Now, here's the deal. Smooth curve. Do your best. It takes a lot of practice, guys, to draw a parabola nice and pretty. Make a smooth curve. Put arrows at the end of your lines, and that's a parabola. Okay. So we did 1, 2, 3, 4, 5. We did 6 points. We actually did -3. We just didn't put it in our table, and that's okay. Guys, the key is to start looking for the points that are across from each other and then that symmetrical aspect. So, do you guys understand what the word symmetry means now?
Yeah.
Is that U symmetrical? The same on the right as it is on the left? That's what you're going to look for. Okay? Oh, I should have mentioned this on this first one, but we'll mention it here. Let's graph -2x squared. Y equals -2. Does anybody know anything? Can anybody say one intelligent comment about that U before we even graph it?
It's going to go down.
It's going to open downward. Guys, always do something like this. Because the coefficient of the x squared is negative, because the thing in front of the x squared is negative, it's going to open up downward. It's going to look like that kind of a U. All right, let's try 0 first. -2 times 0 squared. Take your time, talk yourself through it. Katie Harms, what do you think y is when x is 0? Still 0. 0 squared is 0, times negative 2 is still 0. So this one also goes through the origin. Okay? Let's try 1. Definitely use parentheses here, people. Look how I wrote that. Y equals negative 2 times the quantity of negative 1, and then your squared goes outside your parentheses. Try to do that in your head.
-4.
I don't think it's negative 4.
It's -2.
Still negative 2, right? 1 squared is 1 times negative 2. Do your order of operations. PEMDAS. What do you do first, people? Parentheses. Then exponents. We got to square. Always square your x value before you multiply. That's where I think you got 4. If you do the wrong order of operations, you do get 4. Multiply and then exponent. That's wrong. Let's do square our 1. That's 1 times negative. So it does make negative 2. So the point 1 negative 2 is here. And notice we're going down. It's going down instead of going up. Okay? Let's try 2. Y equals negative 2 times 2 squared.
Look at it.
Do your order of operations. Raise your right hand when you got that number. Come on, let's go. Everybody push yourselves. I got to do it. Teddy, what is it? I got negative 8. 2 squared is 4 times negative 2 is negative 8. 2 comma negative 8. 2 comma, well, we're at the very bottom of our graph already. Okay. Should we try 3?
No.
Okay, and I think we get a big number. Let's do it. Let's 3. What's 3 squared?
9.
Times negative 2.
18.
Nice
Negative
try. Negative 18. Because we'd be way off. We don't even have enough space to estimate it. So let's not try 3. Let's try negative 1. Here's where it gets tricky. Here's where kids are going to make their mistakes. Squaring negative numbers. Use parentheses and be careful. Y equals negative 2 times negative 1 squared. Who's got that one? That's tough. Ooh, not tough. Just got to be careful. I do. Trace, what is it?
-2.
I got negative 2. Negative 1 squared, because it's got parentheses around it, is going to make positive 1. Negative 1 times negative 1. Positive 1 times negative 2 is negative 2. Negative 1, negative 2. All right, are we starting to get points that are across from each other?
Yeah.
That's a good thing. We've got our parabola going on. I bet if we try negative 2, we're going to get a point across from that. It's probably going to be negative 8 again.
Mm-hmm. It is.
Is it?
Yeah.
Negative 2 squared is 4 times negative 2 is negative 8. We get negative 2, negative 8, and right here. And I think we're good to go to try to graph it. I missed that point a little bit, but that's it. It's not a V, guys. Mine looks like a V. It should be more like a U-shaped thing. Mine looks like a V. Go ahead, Henning. Good.
Does it always go through the origin?
That's the smartest question. As long as there is no x after the x squared. If they did this, don't write this down, but watch. Y equals 3x squared plus 4x minus 1. That one doesn't go through the origin. This moves it left and right.
Oh, I get it.
Okay?
So it's only if it's like,
It's only the x squared.
okay.
So guys, the 4x, just watch, don't write this down. The 4x, if there's an x in there, notice I don't think any of your examples have an x in it, so they're all going to go, well, I'll have to explain the other part. So the b, remember it was ax squared plus bx plus c, the b part, or the x, that moves it left and right. Guess what the c does? Moves it up and down. That's what we're going to deal with. So we're not going to have the x's, but we're going to have a constant at the end. That number actually moves it up and down. So, but no, they all don't go through the origin. But when we're just learning this, a lot of them are going to be real close to the origin. Great, very smart question. All right, jump to the next one where we actually have a c. Okay, C is 4 in this problem. Everybody, raise your hand if you know whether it opens upward or downward.
Upward.
I don't think it opens upward. It opens downward because it's negative, so it's going to go like this, okay? And it is not going to go through the origin because of that plus 4. It's going to move somewhere, okay? Ange, what do you want to say?
We're not allowed to use a 0 because of the negative of the x, right?
Good point, but yes, you can. And here's the deal. That's my next point. Guys, look at this carefully. Is the negative, this is what Angie's thinking about. Is the negative sign being squared?
No.
No, just the x's. So that's why we've got to use parentheses. Watch this, Angie. So y equals negative x squared plus 4. We're going to try 0 first. Y equals negative, start some parentheses, put your x value in there, in this case 0, square it, and add 4 to it. Use parentheses. Ange, how much is that?
Negative
I don't think so.
4.
4.
4.
Just 4.
Just 4. 0 squared is 0. Negative 0, it doesn't.
Oh, I didn't add.
Right. Don't forget to add 4. The 0 is not positive or negative, so it's still just 0. Add 4, we get 4. So this one, back to Miss Henning's point, does not go through the origin. It goes through the point 0, 4. We're going to talk about that in a minute. All right, next best x value to choose. 1.
No.
Negative, parentheses, 1 squared plus 4.
2.
3. 3.
2 or 3?
3.
3 is 3.
What's 1 squared?
1.
1. What's the opposite of 1? That negative sign comes into play after you square it.
Negative 1.
Negative 1 plus 4 makes 3.
Oh, I thought you added it too.
Say again. You thought
I
what?
thought you added the negative
Oh, the
sign
negative-
inside the parentheses. That's what I did.
Right. That's hard. That's a real hard concept. Wait till we do a negative number. It's really going to blow your mind. Okay? That negative sign is not being squared right off the bat. Okay? So the 0.13. Ooh, and here's our downward move. Remember, we know it's going to go down. Okay? Let's try 2. Pedalcow, what do you want to say?
If it is a negative, wouldn't it become a positive?
Yes. But then the negative sign in front turns it back to a negative. Think about that. 2y equals negative, parentheses, 2 squared plus 4. Try to do that, people. You got to raise your right hand. That's tough.
It's easy.
Think. Oh. Henley?
0.
0. 2 squared is 4. The negative sign in front of it makes it negative 4. And negative 4 plus 4 makes 0. 2, 0. Boom. It's starting to become that U-shaped figure. Let's try 3. Y equals negative 3 squared plus 4.
Can I skip right through
Don't say it out loud.
Could you skip?
Can you just like not do 3 and do negative 1?
No, we're going to do 3 here.
I did 3 and it messed, like,
Wait, how do you know when to do 3 or not to?
because I did 3 and it wasn't.
You have to, you should always try it, but if you are smart enough, and I think you are, Phoebe, to say when you put 3 in, the number's going to be so big that it's off the graph, then you don't have to try it. Here I know that 3 is going to make it be on the graph. Okay? Who's got 3?
I do.
Raise your hand. Let's go. Push yourselves.
No, because that would be
Catherine, what do you think it is? I got negative 5.
Yes, what did I?
Negative 5. Explain, Catherine, so maybe you can. It's 9. That becomes negative 9. Plus 4 makes negative 5. So 3 negative 5. Boom. It's way down here. Okay? 4 is going to get so big, we're not going to do 4. Let's go to negative 1 now.
I got the answer for this one.
Watch one. Guys, write this one carefully.
What happened?
Negative, parentheses, negative 1 squared, plus 4.
I got it. I got it.
If you can do that, you're really
I got it.
doing a good job. Allie, what do you think it is? I got 3. Negative 1 squared. We're squaring the negative 1 now because that's the x value. That makes 1. The negative sign in front of it turns it back to -1.
What is this?
Plus 4 is 3. -1, 3. Boom. Are we starting to get points that are across from each other?
Yeah.
Guys, you're going to get to the point where you don't have to do too much of your... What do you think -2 is going to make? It's probably going to make
2, 0.
opposite of the +2, so it's going to make 0. And then the -3 is going to be opposite of the +3, so it's probably going to make a 5. Or excuse me, a -5. Okay? So I'm going to put a 0 here. -2, 0. Now I'm going to graph my parabola. Or my quadratic. Okay? Big Jack.
Would it be wrong if you only graph the first 5 points?
No. That's the minimum. Is 5. You should do the extra 2 just to make sure that it's making this U-shaped thing. But if that's the guys, what's the word minimum mean?
The least.
Smaller.
Least. Okay? You have to do at least 5 points. I did 6 and just did 7. Okay? So you gotta do at least 5 points. Alright? Alright, how many people think it's a pain in the rear to graph these things? Well, it takes a lot of time. And look at all the places you could make a mistake. All the math. You know, look at this whole column here, all this math you're doing in your head. Right? Oh, back to my point. Wait, stop. Look. How did the +4 affect the parabola? What did it make the parabola do?
Go up.
Make it
Go up how many?
4.
It went up 4 without any work. Guess what this next one's going to do?
-4.
It's going to go down 4. Okay. Oh, also, we haven't mentioned this word yet. Right when the parabola turns, right when the U turns, what's that point called?
The vertex.
The vertex. Everybody say vertex.
Vertex.
The okay? You don't need to know that word now, but next year. Guys, next year they're going to teach you guys in Algebra 1, they're going to teach you how to graph these in about 30 seconds instead of making this big table. There's a way easier way to graph these.
Why don't we just do it
That's what last period asked.
now? Why do we always have to do it all the way? Because it teaches us through how
You guys got to know where this stuff comes from. Okay? You got to know that by graphing ordered pairs, there's a pattern that makes this U-shaped thing. Okay? Once you know that, okay, this is what's going to happen, they're going to teach you the -b/2a, the axis of symmetry, a bunch of things next year. So, you guys have already caught on to the main thing. The C is how far it moves up or down. That's good. All right, try that next one. Y equals 2x squared minus 4. Let's try 0. 2 times 0 squared minus 4. Dev, what will y be when x is 0?
0.
Keep going.
4.
Close.
-4.
-4. Take your time when you do that. 0 squared is 0, times 2 is 0, minus 4 is -4. There's the vertex, people. 0, -4. Oh, does this one go up or down? Up. The coefficient of the x squared is positive. That means it goes up. Okay, let's try 1. Y equals 2 times 1 squared minus 4. Raise your hand when you got that value. Pabon, what is y when x is 1? Is it right? -3? No.
-2.
I think it's -2. What's 1 squared, Antonio? Times 2. Minus 4. -2. So at 1 we're at -2. All of a sudden it's rising up. 1, -2. Let's try 2. 2 times 2 squared minus 4. Okay, try to do that in your head, guys. Oh, stop. What's y when x is 2? 4. Okay, 2 squared is 4. Times 2 is 8. And 8 minus 4 is 4. So we know the point 2 and 4. Okay, it's going to get 2, 4 goes. Okay, do we want to try 3 or not?
No.
Can anybody do 3 in our head real quick? 14. Okay.
Wow.
9 times 2 is 18 minus 4 is 14. We're way up here. Let's not do that one. Let's go to the negative 1. 2 times negative 1 squared minus 4. Hopkins, what's y when x is negative 1? It's not even the right side. When I call on a kid to do a problem, they turn their notes over.
Negative.
I got negative 2. Very good. Negative 2. Negative 1 squared is positive 1 times 2 is 2 minus 4 is negative 2. So negative 1, negative 2. All right, start to see that symmetrical aspect. I bet it when x is negative 2, I bet y is 4. 2 times negative 2 squared minus 4. Make sure you're using parentheses. Okay? That does give us a 4. So negative 2, 4. And we already got that graph. Make your curve, guys. Make your parabola. Okay? Again, you guys have 9 problems to do tonight. Okay? And we give you the graphs. We give you the graph paper.
What about table?
Okay? The table, you're going to have to make your own table. And that's what you got to do on SSOP. Okay? All right, let's try one word problem. We'll save the other word problem until tomorrow. Oh, no, we already did these.
That's the number 6.
That's example 5, right? Example 5 is a word.
Where did those come from? Is that the one I just did?
Yeah.
That's weird. Like an extra page got thrown in there. All right, here we go.
6.
The word problem. All right, guys. You were going to do a ton of quadratics, parabola problems in high school because, guys, what kind of shape is formed? Ever pretend you have a ball in your hand, football or baseball, and you toss it as high as you can up in the air. The path that ball travels is what kind of shape?
Yeah, you.
Oh, that was one.
Upside down you.
It's a parabola.
Okay.
Have you ever gone to like downtown to like, I don't know if it's like Millennium Park or whatever, and you like a fancy building, and they got one of those little things where water shoots out and makes like a.
Las Vegas.
Well, yeah. What would that think? Like a fountain that shoots out water, but not straight up. It's got some kind of angle to it. What kind of shape is that water?
A
A parabola. Okay. Guys, there were mathematicians that made those things, and there were engineers that made those things. Where's there one uptown, Maeve?
Like by Noodles and like
Is there a little water thing that shoots out?
Shoot straight up.
So,
Oh no.
guys, and all that stuff is made by engineers using math. Okay? Alright, the function a equals 0.2 v squared. Okay, models the do you guys know what acceleration is?
Yeah.
It's like picking up speed. You're accelerating. Okay? Of a carnival ride. Guys, a carnival ride starts out kind of slow and then speeds up. Okay? Where a is the acceleration toward the center of the ride in meters per second. Every second. And v is the velocity in meters per second. So we're going to graph this function. And then we're going to use our graph to estimate the velocity of the ride at an acceleration of 1 meter per second. All right. They're using different variables than x and y. Which one do you think is x and which one do you think is y? Say something intelligent, people. You're on film. You're being taped.
I got a remote.
Antonio?
I like pi.
Yeah. Guys, a is y and v is x. Okay? So, a is going to be y and the v squared is going to be our x squared. All right. We got to label this stuff. Here is our acceleration on the y-axis there, guys. There's our acceleration. And that's in meters per second. Squared, actually. All right, and then our velocity is our y-axis, and that's in meters per second. Okay. Why are we only dealing with quadrant 1? How come we don't have the whole coordinate system up there? Say something intelligent, people.
Because you
Equals
can't
x.
go negative speed.
Yeah, but your velocity can't be negative, and your acceleration cannot be negative. Okay.
Accelerating.
So here we go. A equals 0.2 v squared. And remember, x is v, and y is a. So I'm going to label my columns above them v and a as well. Remember, x or v is our input, and y is our output. Okay. Best one to choose right off the bat.
1.
0.
Always choose 0. Let's put 0 in for v. A equals 0.2 times 0 squared. I don't think you need a calculator on this one. 0.
Yay.
Goes through the origin. Guys, before that carnival ride starts moving, when the velocity is 0, how much is it accelerating? 0. Nothing's happening at time 0, at velocity of 0. Well, let's try 1 with the velocity of 1. So equals 0.2 times 1 squared. I bet you can do that one without a
0.2.
calculator. 1 squared is 1 times 0.02 is 0.2. So at 1, it's 0.2. The graph is nice and neat for us. Okay, let's try 2. A velocity of 2. This you're going to need your calculator. All right. Here's how you use your calculator to your advantage, guys. You can all square 2 in your head. What's 2 squared?
4.
Type in 4 times 0.2.
0.8.
0.8. The acceleration's getting big quickly. So at 2, it's at 0.8. And then let's try 3. A equals 0.2 times 3 squared. 3 squared is 9. And then just hit 9 times 0.2.
1.8.
1.8. So at 3, it's 1.8. There's our... Guys, this is only the right half of the parabola. Look at this. Now we're going to graph it. Make a smooth curve. And then, if we finished off the parabola, don't write this, but it would look something like this. But this green part does not count.
Wait, how come we didn't
Okay.
do another thing?
Say again?
We didn't do the...
You could do 4, but I think you're going to be way off the graph. So I just did 0, 1, 2, and 3. Don't try any negative values in this type of word problem because
There's no
the
other negative side.
velocity can't be negative. Okay? We're going to save the other word problem for tomorrow. All right, let me give you guys your homework. That was a lot.